Hi guys, these are your notes for the first couple sections of Chapter 6. We will be discussing exponential functions in this chapter, so we're going to be talking about stuff that doesn't grow in a linear fashion. We did linears where you have graphs like this, so a real-world problem will be something that's increasing or decreasing at a constant rate. And then we've done quadratics in Chapter 5, so you've got graphs that look like this or like this, and certain things apply to a quadratic function. Well, in Chapter 6, we're going to be discussing exponentials. And exponential functions are ones that either grow or decay in a way like this. So they start off, nice and slow, and then they take off and get really steep really fast. Or something that's decaying will lose a lot of value fast, and then it starts to level out. So these are the two styles of functions we'll get to towards the end of this chapter. But for the first couple sections, we're just going to be working with some basic exponents and getting our math skills out of the way before we start worrying about the word problems. So first of all, just with the extreme basics, exponents, x to the fourth, I'm sure you know this, means multiply x together 4 times. Some terminology which you might not know. I know you know these words, but you might use them interchangeably, and I will try to do my best to use them correctly. In x to the n, the x is called the base. The n is called the exponent, and the whole thing, x to the n, that's called a power. Usually the mistake that's made here is calling n the power. Not a huge deal, everybody knows what you mean anyway, but just so we're correct, that is what those words mean. So as far as writing these things, the one thing you need to know is that the exponent only applies to the base that's right under it, unless there are parentheses. So this means x times y times y times y times y. And this means xy times xy 4 times. Or x to the fourth, y to the fourth. And that's one of the properties that we'll use later. But just the point of this is, if you have an exponent, it only applies to the thing that's right to its left, unless there are parentheses. And the one practical time where this could come back to haunt you is in a calculator. If I go to my calculator and I'm just moving fast and I'm thinking, okay, what is negative 3 squared? Okay, my calculator tells me that negative 3 squared is negative 9. Which we all know is not true because all squared numbers are positive. And hopefully you would catch that and realize that your calculator does order of operations, and it squares first, and then it applies the negative, multiplies by negative 1. So your options are to either just remember that it's always positive, or to put it in parentheses. And if you were squaring negative 3, hopefully you wouldn't be going to the calculator anyway, but let's say you're squaring negative 12.45, a number that you probably don't know how to square just in your head, and you do this and you're not paying too much attention and you write negative in your answer. Just realize that that squared only applies to that number right next to it, unless parentheses are included. Okay, so that's from 6-2, that's all the notes, and then we just have some problems, and I think those will go pretty smoothly without too much problem, but I'll just give you a couple of examples. We have something like 3 divided by 2 to the fourth. That would be part A, and part B is 3 divided by 2 to the fourth, and then we have 3 divided by 2 to the fourth. So these problems are just getting you to think about these rules. 3 divided by 2 to the fourth, the first one, I would think of it as 3 divided by 2 to the fourth. And then 3 to the fourth is 81, and 2 to the fourth is 16. So 81 sixteenths, and then there would be a decimal number that corresponds to that. In part B, 3 divided by 2 to the fourth, the 4 does not apply to the 3 because of the parentheses. So this is 3 divided by 2 to the fourth, or 3 sixteenths. And then in part C, you might be looking for something different, but if you just have parentheses around a 2 like this, they don't mean anything. If you put parentheses around one single entity, then, you know, it doesn't, they don't affect anything. So this is 3 divided by 2 to the fourth, or 3 sixteenths. The problems are all similar to that. They are just making sure you are up to date on your exponent practice. So we'll save some of those for in-class time. There's not going to be too much of a problem in section 2. So let's just move to section 3, which is properties of exponentiation. And we've got 5 main rules. Again, rules that you probably know. You've probably seen these before, but we'll just review them quickly in this section and then practice some of it in class. The first one is the product of 2 powers. Let's just call these exponentiation rules. And the first one, product of 2 powers with equal base, is just what do you do with x to the a times x to the b? And that's going to be x to the a plus b. So you have x to the third times x to the fourth. A common mistake would be to make this x to the 12th, because you see a 3 and you see a 4 and you see a multiplication symbol. But this means 3x's times 4x's, and those multiply together to give you 7x's. It would be, if you wrote it out, write the 3 and then write the 4, and you can see that there are 7 of them total. Most of these rules, if you write them out that way, they make more sense, and it helps you remember not to multiply that 3 and 4 and instead add that 3 and 4. All right, so rule 2 is the quotient of 2 powers, x to the a over x to the b. And similarly, if multiplying is adding, then dividing is subtracting. This would be x to the a minus b. Okay, so just as a side note, just for fun, over here, you will learn or have learned that x to the 0 equals 1, which doesn't really make sense practically because you can't multiply x by itself 0 times. But rule 2 here is one reason, or one sort of mini proof of why x to the 0 is 1. If you consider something like x to the 3 over x to the 3, we can all agree, I think, that that equals 1, because anything over itself equals 1. Well, by this rule, x to the 3 over x to the 3 is also equal to x to the 3 minus 3, which equals x to the 0. And so if x to the 3 over x to the 3 is 1, and it's also equal to 0, or to x to the 0, then these two things must be alike. Okay, so that's just something on the side, and there are other ways to show something like that, but sometimes we have things that don't really make sense as far as the definition of an exponent, but there are reasons behind them, and there's one reason for that one. Okay, so moving on to number 3, the power of a power. If you have an entire power, that's the base of another power. Now is where you multiply the x, or the a and the b, x to the ab. So like x squared to the third would be x squared times x squared times x squared, and then you would have 6 x's total, so 3 times 2. The power of a product. Product xy, all raised to the a power. Okay, this is equal to x to the a, y to the a. So in a sense, you sort of distribute that a to the x and the y, but I can't stress this enough. That's okay. Another side note, x plus y to the a is not x to the a plus y to the a. You can't distribute an exponent over addition. You can over a multiplication. And rule 5, the fifth and final rule, is the power of a quotient. X over y to the a is x over a, x to the a over y to the a. So you can sort of distribute that a top and bottom as well. All right, I'll do a quick one, example, and then we'll leave the rest for class. So let's do just something like this. We have 5x squared to the third, and 100x to the fifth on the bottom. So a couple of those rules apply right here. I'm going to start on the top, and I have a couple issues here. I've got the power of a product, which means that I need to distribute that 3 to both parts. And then within that, I'm going to be doing the power of a power. 5 to the third is 125, and x squared to the third is x to the sixth. I'm distributing that 3, and I'm also doing the third power of x squared. And on the bottom, nothing to simplify yet. I have 125 over 100, which is just 5/4. I divide by 25. And then x to the sixth over x to the fifth. You do 6 minus 5, and you get 1x left on top. Or you can consider it 6 x's canceling with 5 x's on the bottom. So 5 of them cross out, and 1 of them stays. Okay, so there are a couple of different styles, but I'm not going to do all of them here. We will do most of those in class. I will see you then. Young out.